Hello, my name is Isabella and I will be your host for another mathematics video brought to you by RJ. In the previous video, I derived a more compact integer test function. If you haven't watched it, I suggest watching it now. The integer test function produces a 1 when the inside function is an integer and a 0 when the inside function is not an integer. My question for you today is there a non-integer test function? In other words, we want the opposite, a function that produces a 1 when the inside function is not an integer and a 0 when the inside function is an integer. I'm going to denote the non-integer function by I to be -1, or the inverse of the integer test function. This is a simple way of expressing the non-integer test function. Just subtract the integer test function from 1. But can we make this more compact? Intuitively, since 1 is an integer, it seems we could move the 1 inside the floor bars. Then, we can use substitution of the trigonometric identity, which reduces to this. However, there is an issue here. Here, we are taking the difference of two integers. But here, we are taking the difference between an integer and a number that may or may not be an integer. If the number is not an integer, then the difference is also not an integer. The floor of the non-integer difference equates to 0, which is not what we want. So, what can we do? If this evaluates to either 0 or 1, then the floor bars are fine. But what if this evaluates to a number between 0 and 1? Then this evaluates to a number between 0 and 1 whenever the inside function is not an integer. And since, by definition, we want this to evaluate to 1 when the inside function is not an integer, we can just take the ceiling instead. We swapped out the floor with the ceiling. Note that the floor of 0 is 0 and the ceiling of 0 is 0. Also, the floor of 1 is 1 and the ceiling of 1 is 1. So, the swap has no effect on integers. Not only do we have a closed formula, but a more compact formula for the non-integer test function. Can you think of any ways this could be important or helpful? I hope you enjoyed the video. If you did and would like to see future videos, please like and subscribe. Also leave a comment telling RJ which areas of math you find interesting. Thank you for watching.